Hey there, next thing we're going to be talking about is our segment length. Okay, so we've done lots of stuff with angles, so now we're going to be focusing on all the lengths of those lovely tangents, secants, and chords and diameters and all that stuff, and looking at some new relationships. The only one we really only been talking about angles. So here's some new guys for you to add to your lovely theorem sheet. All right, so here's our first one. It's called the chord product theorem, and that's when we have two chords that are intersecting on the inside of a circle. The product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Well, that's quite the mouthful, huh? Sorry, I know you enjoy that noise, huh? Okay, so here is what that is saying. So when we have these two chords, they're intersecting at some point. So this point E here is cutting this into two separate sections. They're not necessarily congruent to each other, although they could be. That's if they were essentially both radius. But what this is saying here, and that's a time sign, so make sure you recognize this. This is taking the product of EA, multiplying it by EB. That product is going to be equal to if I did EC times ED. So if I find the product of this guy and find the product of this one, those two should be equal. So we're going to be finding some missing lengths there. All right, now that we're done with talking about inside, so that's the only case of inside, now we're going to be talking about a secant and a secant. So there's two cases where we're going to be meeting on the outside of the circle. The first one is the two secants here. Okay, so it looks like this. And the way I always kind of think about it is always it's part times the whole equals part times the whole. So the external piece times the entire thing should equal the external piece times the entire thing. Again, this is a times sign. I know it looks like a decimal there, okay? So we're going to take EA, whatever that length is, and multiply it by the length of the whole thing, EB. And then when you have EC, that length, we're going to multiply it by the length of the whole thing, ED, and that product, they should be equal to each other. And our next one here is a secant and a tangent, should be our last one. With this guy, we are dealing with a tangent, so therefore there is no internal piece with that, like the secant. And so our outside piece times our whole length is actually going to be the exact same thing for the tangent piece. Okay, so we're going to do EA times itself, okay, because that represents the outside portion and the entire segment. So we're going to do EA times EA, or in other words, EA squared. And that's still going to be the outside times the whole. So part times the whole for that one there. Okay, so you can see it's kind of similar to the tangent. All right, let's use those theorems in a couple of examples here. So here's our first one. This is the inside pieces. So we know that this little piece that's getting cut up is going to be equal to the product of the other two here. So we're going to do 3 times 6 equals 9 times x. Well, 3 times 6 is 18, divide both sides by 9, and we get x is equal to 2. Okay, so these are the very straightforward ones. Your practice will get a little bit more difficult. We have to think back to what we did from 8.1 and some of those things we're going to have to FOIL or multiply binomials, but you'll see in that practice there, okay? All right, let's take a look at this one. Actually, that might be an example. We'll see. So this is dealing with two secants. So remember, it's always part times the whole. So the first one will be LM times LN. And then we'll do LO times LP, sorry. So when I do LM, it's still 9. When I talk about LN, I'm going to combine both 9 and 11 together to get 20. For the other piece, though, I have LO times the whole thing is going to be represented by the expression 10 plus x. Okay, so for this one, you're going to have to distribute through with the 10, and I get 100 plus 10x. 9 times 20 is 180, and then from there, we're just kind of using algebra. So subtract 100, divide by 10, so the x value is equal to 8. So the hardest part about this is getting this set up here to make sure that's correct, and then from there, it's just using algebra. Okay. Same thing with this one. Excuse me. Remember, with the tangent piece, the part and the whole represent the exact same length. So we're going to do CB squared. And then the other portion will be CD times the whole length CA, so part to whole there. So we'll end up doing 24 squared equals 12. And then CA we find by doing 12 plus X, the whole quantity there, okay? All right, distributing through, we get 144 plus 12X. 24 squared is 576. Subtract and divide, and the value of x is equal to 36. Okay? All right, why don't you go ahead and give it a try. Let's see how you can do with these, and I'll go over the answers in a moment. Okay, so our setup here, you should have done 9 times 12 equals 18 times x. Multiply 9 times 12 and divide to get x is equal to 6. Hopefully you got that right answer. How about this one? Go ahead and give it a try. Hit that pause button. All right, let's see how you did. You should have done 11 times 21, not 11 times 10, 11 times 21, the whole length there, equals 12 times 12 plus x. You distribute, subtract, and divide. So this one does get you a decimal. That's okay. Decimals are okay. Most often we won't get them, but it can happen. 7.25 is correct there. Try this one now. Okay, so for this one, we needed to take the 10 and square it. Excuse me, the 10 squared, and then 5 times 5 plus 3x. So in this case, it's not just x, it's 3x. So I'm going to distribute while I square out that 10, subtract, and divide. Hopefully you didn't have any too many issues with that one here. Okay, now when you get to your practice, you're going to see some where there's going to be values of x, and you're going to end up with some x squares. Don't panic. Okay, but remember when we talked about that in 8.1 where we did the stuff with the radius, we ended up having to do x plus 7 times x plus 7. So go back to that kind of thinking where we have to multiply binomials through FOILing or the box method or distributive properties. So don't be so panicky when you get to that, but if you do need help, go ahead and ask your teacher. All right, hit that stop button and get to practice.